Hello students, I am Nageswar Shah from science classes. Today I am going to discuss about some numerical related with the first chapters. Okay. And before I'm talking about the some numericals, and first of all we have to write the some important formula and which is important in this chapter. First, gravitational force. If m1 and m2 be the two masses separated d distance from each other, then gravitational force act between those two body is g m1 m2 by d square. And when we have to calculate the gravitational force between the two body, then we apply this formula. Another, when we have to calculate the gravity of any planet or any heavenly body by placing a object having a small mass, then that force of gravity is equal to g m by d square. And this is the force of gravity exerted by the heavenly body having mass capital M on the a small body having mass small m. Another, when we have to calculate acceleration due to gravity on any planet or heavenly body, then we have to take their masses, we have to take their mass and radius, like as I have derived this formula in previous classes, gm by r square. This, where g is the universal gravitational constant, and which value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. We have to put this value in numericals, and this value is constant, and which we have to take. Another is when we have to find the acceleration due to gravity at s height from the earth surfaces, then we have to take this formula gm by r plus h and whole square. And this is the formula when we have to calculate the acceleration due to gravity at s height from the earth surfaces. Okay, these all are the formula and which is used to determine the which is used to calculate different numericals. Another formula is g1 is equal to g r by r plus h whole square. This formula. Okay. Another is about the some numericals I am going to discuss. Here f is equal to g m1 m2 by d square, where g is universal gravitational constant, m1 is the mass of the first body, m2 is the mass of second body, and d is the separations between them. Here, when we have to calculate the what that is gravity or gravitational force between the two body, and where one is heavenly body, another is a small body, then here capital M be the mass of the heavenly body and a small m be the mass of a small body, and d be the separations between them. Or here instead of d we can write r also, okay, because here in heavenly body and we have to take the r, we can take r also because that present on the surface of heavenly body. Okay, in this way we can write also. Another, when we have to find the acceleration due to gravity of any heavenly body, then we require their mass and radius, gm by r square. Another, when we have to calculate the acceleration due to gravity at s height from the earth surfaces, then their value is decreases, we already know, and that value is equal to gm by r plus h whole square. Another, this is a relations among the radius and radius of heavenly body and its height from the earth's surfaces, and g1 is the acceleration due to gravity and s height from the earth's surface, and g is the acceleration due to gravity on the earth's surface. Then we can write this relation or formula: g1 is equal to g into r by r plus h whole square. Okay, after this I am going to solve the sum numerical related with this chapter. Here in sum numerical I am taking from first chapter, and here first numerical is a sphere of mass. Here one number, a sphere of mass m1 40 kg, and another mass m2 15 kg, and with force of attraction already given, gravitational force of attraction F is equal to 9.8 into 10 to the power minus 7 Newton. Then find the value of universal gravitational constant if separation is 20 centimeter and g is equal to what? Here, dear student, we have to calculate the value of capital G, and that is not mentioned. Then first of all, and we have to write given. In any numericals, the first of all we have to write given, and what are given in the questions, that we have to write at first. Like as here m1 is the 40 kg, m2 is 15 kg, and F value means gravitational force of attraction between them are given 9.8 into 10 to the power minus 7 Newton, and d is equal to 20 centimeter distance between them. Then here distance is not in SI unit, and so we have to change this CGS value in SI unit. 20 by 100 is equal to 0.2 meter. Okay, and first of all we have to write givens, and after that we have to search that all quantity are given in SI unit or not, and if not, then we have to change in SI unit, and then we have to apply the suitable formula to calculate the given, to calculate the quantity. Like as here g we have to calculate, then first of all we know that the formula, main formula is F is equal to G m1 m2 by d square, and this is the main formula, and from this formula we have to find the formula to calculate the universal gravitational constant, and g is equal to f d square by m1 m2. Okay, and by this formula, and we can calculate also, like as I am going to write here, f means this much 9.8 into 10 to the power minus 7 d square 0.2 whole square by m1 m2, m1 40 kg and m2 15 kg. Okay, in this way we can calculate. After that we should calculate this all value, and after calculating this value of the universal gravitational constant we find. Okay student, and when we write this g value, then here unit you should write Newton meter square per kg square. Okay, and after this another type of the numericals I am going to do, and this value you have to calculate yourself. Another numerical is accelerations due to gravity at the surface. Acceleration due to gravity at the surface of the moon is 1.6 meter per second square. Here value of g already given, 1.6 6 meter per second square. Another, if the radius of the moon is 1.7, r is already given, 1.7 into 10 to the power 6 meter. Calculate the mass of the moon. Then mass of the moon is equal to what? Then dear student, we already know here capital G value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And we have to calculate the M. Capital M means mass of the moon. Then main formula we know that G is equal to Gm by R square. This is the main formula. Then here we have to calculate mass, then we can write in this way. M is equal to G R square and by G. Then here G is equal to 1.6 into R, 1.7 into 10 to the power 6 square by G, 6.67 into 10 to the power minus 11. And after calculating this, and we can find the value of M, and that value we have to write in kg. Okay, and in this way we can solve the different numericals related with these chapters. Okay, this much for today. In another day I will bring another chapters.